Good morning. NEET JEE Entropy calculations for irreversible processes. The procedure of delta S calculation for an irreversible process can be illustrated by solving the problem written here. 2 moles of an ideal gas is expanded to twice its volume irreversibly and isothermally at 37 degrees Celsius when it absorbed 3.41 kilojoule of heat from the surroundings. The delta S system plus delta S surroundings for the process is 4 options. Number 1, minus 0.52 joules per Kelvin plus 0.52 joules per Kelvin, 22.52 joules per Kelvin. The fourth option is 0. Entropy being a state function, the entropy change of a given process, that is a given initial and final state, is always the same whether the process is conducted by a reversible path or an irreversible path. That is, for a given process, delta S reversible is equal to delta S irreversible. But the calculation of delta S from the heat value requires the knowledge of Q reversible, because for an isothermal process, delta S is defined by the equation equal to Q reversible by T, and Q reversible of course greater than Q irreversible. From the Q irreversible value, you cannot calculate delta S. So we have to devise a method for the same process to be conducted in a reversible manner. And it is well known that for a reversible ideal gas isothermal process, being isothermal, delta U at constant temperature is 0 from first law, that equals Q reversible plus W reversible. So Q reversible is equal to negative W reversible, substituting the standard formula for reversible work. Finally, you get nRT ln V2 by V1. So, delta S of the system is calculated as Q reversible by T or nRT log V2 by V1 by T. T cancels off, converting natural logarithm to the base 10. We have 2.303 nR log V2 by V1, substituting the values 2.303, N is equal to 2 moles, R is equal to 8.314 joules per Kelvin per mole, and V2 by V1 is 2, so multiply by log 2. That will simplify to 11.52 joules per Kelvin. Now let us calculate the delta S of surroundings. Delta S surroundings by the same definition is Q reversible by T. Surroundings. Given in the problem, Q irreversible system is plus 3.41 kilojoules. Therefore, Q irreversible surroundings is minus 3.41 kilojoules. The negative sign implies that surroundings lose heat during the process. By definition, surroundings is rest of the universe. It is so large that a small amount of heat loss or gain will not affect the properties of the surroundings. It is as if adding a small amount of water or removing some water to the ocean does not affect the water content of the ocean. So, for all practical purposes, any heat lost or gained by the surroundings can be considered as in a reversible near equilibrium without changing the properties of surroundings. Therefore, delta S surroundings is equal to minus 3.41 kilojoules. Whatever heat value, it is considered as a reversible heat. divided by the temperature of surroundings, which is 273 plus 37, 310 Kelvin, or negative 3.41, 10 raised to 3 joules per Kelvin, kilojoules. It is converted to joules, divided by 310 Kelvin. This simplifies to plus 11.0 joules per Kelvin. So the sum of delta S system and delta S surroundings will be plus 11.52 minus, here we have the answer as a minus value because each value is minus. It is minus 11.0 joules per Kelvin. So this minus 11.0 will be equal to plus 0.52 joules per Kelvin. The correct answer is option 2. I hope the concepts behind the calculation are clear. See you later with more videos.